This video will discuss group punching shear design in VisualFoundation. Let's get started. In VisualFoundation, punching shear checks are performed at locations where concentrated loads act on the foundation slab, such as at piles, column piers, and walls. When piles, piers, and walls are closer to each other than the thickness of the slab, VisualFoundation combines them to form a punching shear group. The critical section for the punching shear group can be seen in the foundation design view of the program. To include walls in the automatically generated punching shear groups, the include walls in groups parameter must be enabled and the wall aspect ratio must be set. Walls with a length-thickness ratio greater than the value specified will not be included in punching shear groups. Walls with large aspect ratios are unlikely to punch and may create undesirable groups. If a grade beam crosses an object's critical section, punching shear checks are not performed for that object, and it is excluded from the group punching shear. In this case, it is assumed that the grade beam will be designed to handle the required shear demands. Punching shear groups expand to include any additional element within their boundary. For example, if an item falls within the reentrant corner of a punching shear group, it will be incorporated into the group. Although the group critical section cannot be directly overridden or modified, adjusting the override perimeter offset for an individual object within the punching shear group will affect the overall critical section for the group. For the group punching design check to pass, the strength of the group's critical section must exceed the net load acting within the area of the group's critical section. The punching shear capacity table shows the punching shear demand, capacity, and the unity value for both the individual objects and for the punching shear groups. Note, this table can also be modified to include all of the components of the free body diagram, such as the applied load, the pile reaction, the bearing resultant, and the footing weight. Using these values for the free body diagrams for column piers, piles, or walls, we could calculate the punching shear demand VU for each object or for each punching shear group. Looking at this table, you will notice that the group punching shear for column piers controls over individual punching of the piers. The punching behavior of a subgroup may govern the design rather than the punching behavior of the entire group or the punching of the individual elements within the group. To demonstrate this, let's go to the Model and Load view and remove everything but the 3 column piers. In the Find tool, we see that the piers are loaded equally with 75 kips each. Let's reduce the load on pier C3 by a factor of 10, from 75 kips to 7.5 kips. Let's also reduce the size of column pier C3, since it will take less load. With a setup like this, we might suspect that group punching of the C1 and C2 pier subgroup might control over group punching of C1, C2, and C3. To allow VisualFoundation to check this, we can enable the Check Subgroups parameter and set the max group size parameter to 3. Note, groups with more items than the specified number will not be checked for subgroup punching. The number of subgroups checked grows exponentially. For example, a group of 3 objects will have 3 subgroups in addition to 1 main group and 3 individual objects. A group of 4 objects will have 10 subgroups plus 1 main group and 4 individual objects, etc. Due to the exponential increase in computational cost as the group size grows, the max group size parameter is capped at a value of 10. This ensures that the user does not request a problem that exceeds realistic computational capabilities. With the check subgroup parameter enabled, we see that the 3 subgroup critical sections are displayed graphically. Clicking on punching shear in the project status takes us once again to the punching shear capacity design table. Setting applies to by object shows the punching shear demand, capacity, and unity value for the one main group, for the 3 subgroups, and for the 3 individual elements. Filtering by unity value shows that the C1-C2 subgroup controls with a higher unity value than the C1-C2-C3 main group. This makes sense as the load for the C1-C2 subgroup is only slightly smaller than the load for the C1-C2-C3 main group, but the perimeter for the subgroup's critical section is significantly smaller than the perimeter for the main group. Additional information on group and subgroup punching shear in VisualFoundation can be found in the punching shear section of the help file, which is accessed by clicking the button in the ribbon. We hope the group punching shear feature in VisualFoundation increases your productivity and helps you provide even more accurate and efficient designs. Thanks for watching and have a great day.